Okay, so today I'm talking about the definition of the square root. And you've used square roots like at the very beginning of class when we were talking about order of operations. But what we're going to be doing this week goes a little bit more in depth with square roots, because we're going to be taking square roots of things that don't come out to whole numbers. So you're going to end up with like some decimals, and we have to simplify things underneath square roots for the quadratic equation and or the quadratic formula. And a lot of people get kind of confused about what is inside the square root, what is outside, and kind of all that kind of stuff. So we're just going to kind of start easing into that kind of, the more complicated things about square roots. So let's start with the symbol. So you guys were researching symbols at the beginning of the class in week 2, and so the symbol is actually called a radical. I mean, we usually call it the square root symbol because when you see it in that form, that's what it means. It means a square root, but it's technically considered a radical because that symbol is used with other types of roots, such as the cube root and the fourth root. So what's really important, and this is super important when you're going to be like typing things into Connect Math, is what is inside and what is outside. So you really have to pay attention to the line on the top. So anything that is under that line, so if you go to the end of the line and then like anything that is to the left of that dashed line is inside the radical. So anything to the right, like so you could have like a 2 there. It's a terrible looking 2. And then I could put maybe plus 5. The plus 5 is outside of the radical. So you have to really pay attention to what is inside and what is outside. And even if, like I saw the number 5 to the right, because the line does not cover the 5 is outside, not inside. So when you're typing stuff up, and even when you're writing it by hand, you want to make sure that the line extends over everything that's supposed to be inside. If you're writing something in Connect Math and you have a number that's inside that's supposed to be outside, it will be marked wrong. Or if you have something, the other way around, something outside that's supposed to be inside, it's marked wrong. So you have to really pay attention to where your cursor is and where the line is. Because this line can get longer. If I want 25 inside there, then the line has to cover all the numbers. But if I only want the number 2, it only covers the 2. So you have to really pay attention to that line and what is inside or underneath it and what is outside of it, because it does make a difference. I get lots of students that complain and they email me and they say, my answer's right, but it's being marked wrong. And it's because they have numbers in the wrong place with the radical. So technically their answer is wrong because the line isn't covering what it's supposed to cover. So you really, really need to pay attention to that. So that's sort of how the symbol is used. And we do have some variations on it where we have numbers that are kind of above the little V part. And those are for different types of roots called nth roots. So if there's a 3, it's known as a cube root. If it's a 4th, it's a 4th root. We don't have special names for 4 or higher. We just have square root, cube root, and then we just basically do the number after that. But it uses the radical symbol, but it means something slightly different when that number is there. And that's not an exponent. It's not like to the left as an exponent. It's kind of right in the symbol itself. So you have to really pay attention, because if you wrote like the 3 and then went like this, that's not the same thing as a cubed root. That 3, that number, is above the V part, and that does matter. It does mean something different depending on where that is. So you really have to pay attention to where your things are placed to make sure that you are indicating the correct thing. Because if you have it in the wrong place, it's going to be marked wrong. And it's not because the system is stupid or just dumb. It's just that mathematically it's technically incorrect because the way we use these symbols, it's very specific on how the symbols are used, and so you have to make sure you're using them correctly and writing them correctly. So we're going to focus on the square root, not the higher roots, though you are reading about those this week. We're focusing on the square root because that's the one that you see the most, which is why we usually just call it the square root symbol. If you see numbers inside the square root and then you're told to simplify or evaluate, what you're doing is you have to take the square root. This is a specific action that you're doing. So you'll hear that something called solving by taking square roots, and that's by doing a square root and then simplifying what's underneath it. So this is a specific action that you take, and when you do this action, the square root symbol usually disappears, although there's some situations where it doesn't. Now, the definition of a square root is actually does not involve the symbol at all. So it says B is a square root of A if B squared is equal to A. So the definition of a square root is defined in terms of exponents, things being squared. If you can square the number and get the other number, then it is considered a square root. So I've got some examples there according to the definition. So 2 is a square root of 4 because if you square 2, you get the answer 4. This means that negative 2 is also a square root of 4 because when you square negative 2, you also get 4. And then if we look at 3, 3 is the square root of 9 because 3 squared equals 9. And negative 3 is also a square root of 9 because when you square negative 3, you get positive 9. So back in week 1, when we were talking about order of operations, we always, whenever we took the square root, we used the positive version. We used, if you took the square root of 4, you would say 2. But technically, there are 2 square roots. There's also a negative version. Every positive whole number has 2 square roots, a positive and a negative version. So when we're simplifying order of operations, we just use the positive version. We ignored the fact that there is technically a second answer based off of the definition. So that's really important moving forward because when we're solving, we use both the positive and the negative. Now there are numbers that have 1 square root or don't have any square roots at all. So 0 is special because it just has 1 answer when you take the square root because there are no signs to 0. 0 is not positive or negative, it's just 0. So it doesn't have a positive and negative version, it only has 1 answer. For example, negative 1 doesn't have a real valued square root because when you square a number, there's no way to square a number and get a negative. Because when you're squaring, you're multiplying by itself, and negative times a negative gives you positive. A positive times a positive gives you a positive. There's no way to get a negative outside of there. So if you have a negative value, there is not a square root, but we specifically say it's no real valued square root because in college algebra you learn about complex numbers and how we can use square roots of negatives. But for now, you don't have to worry about that, so we just say there is no real valued square roots because there's no real numbers that when squared give you a negative out. So that's really important. This is the terminology of the book, is the no real valued square roots. So that's very important terminology. So going back to notation, specifically for square roots, we talked about the radical symbol. So when you have that radical symbol and we start indicating these kind of things, if you see it without a negative sign, we are assuming it's the positive value that we want. So that's why with order of operations, whenever you saw the square root symbol, we always gave the positive version because we assume that's the positive version that you want. And so that's called the principal square root because that's the one that we usually use. With a negative in front, then that gives us the negative square root. And then there's a special symbol that you'll see once we're solving quadratic equations using the quadratic formula is it's a plus and a minus on top of each other. So this is called the plus or minus symbol. Oops, forgot my L. Plus or minus symbol. And it just means that we want both. So that will give us two answers. We want the positive and we want the negative. So whenever you see that plus or minus symbol, we want both of them. You usually end up having to write what you have twice and separate one with a positive, one with a negative. So that's a new symbol, and that's what that means when it's in front of your square root symbol. And then just the square root of 0 is always 0. So just remember that. So again, we usually assume the positive square root. The only exception to this is if we're specifically solving, because whenever we're solving, we want both. So if you're not seeing the word solve, you generally only want the positive version. So that's very important. You have to pay attention to that, the wording there, because that one word solve tells you use both versus just the positive. So with square roots, we need to talk about perfect squares and irrational numbers. So if you have a number that has a square root, and when you take the square root, you don't get an irrational number. It's a rational number. So when you take the square root, you can get a whole number, you could get a fraction, or you can get a decimal that can be written as a fraction. Those are all called perfect squares. So we've got the square root of 64, which is 8. That gives you a whole number. The square root of a fraction, when you do that, you take the square root of the top and the bottom. So that would give us 4 thirds. And then the square root of a decimal, you would actually be taking the square root of 25, and then you have to move your decimal place. It's usually easier to do it with a calculator, but this should, oops, not with the symbol. This will give you 0.05, I think, or 0.05. I always get my decimal place messed up on these, so I'm actually going to use my calculator. 0.5. So that's 0.5 is 1/2, so you can write that as a fraction. So these are all considered perfect squares. 64 is a perfect square. 16/9 is a perfect square. So 64, 16/9, and 0.25 are perfect squares. Because when we took that square root, we were able to get a rational number. Now, there are square roots that don't give you rational numbers. They give you irrational numbers, which means the decimal goes on forever. And actually, most square roots are not rational. Most of the time, they're irrational number. And you have to use these on your calculator if you're going to approximate it. You can't really find it by hand. So your calculator will give you an approximation. It will give you tons of decimal places. And these tend to be, if you take square roots of prime numbers, you'll get irrational numbers. So like the square root of 11, if you did that on your calculator, you're just going to get a lot of decimal places. Square root of 34, square root of pi. So I encourage you to use the square root button on your calculator or whatever calculator you're using. And then you just have to determine, is this a rational number or irrational number? Now, if you're using Desmos as your calculator, it's really easy to tell. So let me pull up Desmos. And I'm going to go to the scientific calculator. So they've got the square root button right here. And so, like, I take the square root of 64. Okay, it's a whole number, so that's good. I could do 16 over 9. So it looks like, it's a decimal, it goes on forever, but you click the button. If you can make it a fraction, that means it's a perfect square. And then we've got the other one, which was 0.25. Again, if you have that ability to turn it into a fraction, then it's a perfect square. But something different, like 11, notice we don't have that button in there. There's no way to make it a fraction. So this is an irrational number. And there's way more decimal places than this calculator is showing you. I didn't know if these buttons would give you more decimal places or not, but clearly they don't. So that's kind of how you can tell from a rational to an irrational number, is basically whether Desmos gives you the fraction button. So for something like this, instead of writing it in the decimal form, we usually leave it in its square root form, because that way we don't have to round and it just looks a little neater than trying to write something with lots of decimals. So if we can simplify it, we do. If not, we leave it in the form of a square root. And so let's do another one, like 34. Again, that one, we don't have the fraction button, so we would just leave it as writing it as like the square root of 34. And actually, out of curiosity, I don't know if this, okay, sometimes there are some calculators that can break the square root apart into different numbers, but this calculator does not do that. So I was just curious. I didn't know if it did that or not. So that's basically the definitions and kind of all that kind of stuff about square roots. Are there any questions so far? Okay, so we're going to move on to then just going through examples just to kind of practice and learn the terminology. So they say determine the square roots. So it's telling you to find the square root, but you're not seeing it written with the square root symbol. But that's fine because you're doing the action of taking the square root. And so what you would do is, like the first one on the top left, I've got 144. What you are looking for is the square root of 144. That's what it's telling you to do. It says determine the square roots. It gives you a number, but you're actually looking for the square root of 144. And so you could use your calculator for that, and your calculator always gives you the positive version. So just be aware your calculator always assumes the positive version. But you can also ask yourself, okay, what number squared gives me 144? So if you know your mental math, 12 squared is 144. So what that means is that the answer, the square root of 144 is 12. So a lot of these you can do without a calculator. You can do them mentally. Let's look at the one to the right of this. We've got negative 64. So we want to find the square root of negative 64. So negative numbers don't have real valued square roots. This is one of the special cases that we talked about. So if you have a square root with a negative inside, there is no real numbered square root. So that would be what you write. You can't actually find this. And if you put in your calculator is going to give you an error. Like, let me bring up Desmos here. And let's do, so calculator gives you undefined. That's not technically the answer. It's just, as far as the definition of the square root is defined as we know it, there is no answer. But that's not what you're going to write. You're not going to write undefined. And my physical calculator when I take the square root of negative 64, it says error, or it says domain error. So your calculator may list something different. But that's not what we're going to be writing as our answer. We're going to say not a real number, or no real number square root. Excuse me. So I often write not a real number. Or sometimes when you're solving, you'll say no real solution. Or you can say not a real numbered square root. So if you're taking the square root of a negative, there is no answer as far as what you have learned so far. Now we have 81. We want to find the square root of 81. So you're asking yourself, okay, what squared gives me 81? And so that's 9 squared. So if you know your multiplication tables, you can find these square roots pretty easily. And I encourage you to basically memorize the square roots for basically up to 144, the main ones for like 1 squared, 2 squared, 3 squared. If you know those squareds, then you will know the square roots. You're just undoing it. Now, bottom row, we've got 0. And that's one of the special cases where the square root of 0 is always 0. There's only one solution. So all of these here, I've been putting the positive solution so far because that's usually what we assume that we want. But notice that I wrote all of these specifically indicating the positive solution. But the problem doesn't actually say that. It says determine the square roots. So there's nothing in the problem saying we did not want these negative versions. So technically for all of the ones, well, not the one in the middle on the top row, but the one where we have 12 and 9 as our answers, we should also have the negative version because they're not giving it to us with the symbol. So if I go back to where I had that slide. So if you see it with the symbol and there's no negative in front, you assume the positive square root. If you see it with the symbol and there's a negative, then you assume the negative square root. But for these examples, the symbol was not given, so we want both because it doesn't specify, because both are technically square roots. So we also want the square root of negative 144, which is going to be a negative 12. And then we also want the square root of 81, which is a negative 9. So oftentimes this will be written with a plus or minus symbol. So let me do that on the 16 over 9. So when it doesn't indicate, then what you would do is you write it with plus or minus, and then you would have your square root part. So here we've got plus or minus the square root of 16 over 9. And so we're looking for what squared gives you 16 over 9. Well, you guys learned about your rules of exponents and that you square the top and you square the bottom. So something squared gives you 16. So that's 4. And then something squared gives you 9, which is 3. So 4/3 squared gives you 16. Essentially what you're doing is, you can think of this as doing the square root separately. You're allowed to do this. If you have the square root of fraction, you're allowed to split the fraction up and do the square root of the top over the square root of the bottom. And so this is going to give us 4/3. And so we have two answers. We have positive 4/3 and negative 4/3. And so instead of writing them both separately, you can write them with the plus or minus symbol to indicate that you need both of them. So we've got another fraction on the right. We have 1 over 25. So it just says determines the square roots. So we want both the positive and the negative. And so this is the same thing as asking for the square root of 1 over the square root of 25. So 1 squared is 1. And that's something that you should just, that's one where you just kind of want to memorize. Square root of 1 is always 1. And then 5 squared gives you 25, so we're going to get 5 in the denominator. So another way to write your answers here is to put them with a curly brace and to separate it out with a comma. This is the most common way that you're going to be asked to do this in Connect Math, is you're going to have to put a comma between them, and then you have one answer with a positive, one with a negative. And you're going to want to be very careful to make sure that the comma is where it belongs. I've seen people when we get into the quadratic formula, and sometimes there's square roots that don't simplify, so we leave it in the square root form. Like when I was talking about the square root of 11. Sometimes people will then accidentally put their comma inside the square root. You need to make sure it's outside. So you want to be very careful on how you're typing your answers so that you don't have things in the square root that aren't supposed to be in there. Are there any questions so far? Okay. So here are some other ways of rephrasing some of these things with square roots. So these are just sort of concept questions. So what is the principal square root of 169? So if you're asked for the principal square root, that means we want the positive version. Okay, and I actually got a question, so I'm going to go back to the other screen. Do we always put plus or minus before the square root for fractions? You don't have to. I did the plus or minus just because of these fraction ones, but the whole number ones, you can also do that as well. So like the 144, I can put the plus or minus right there. And then we still have our two answers, positive 12 and negative 12. So the plus or minus is not related to whether it's a fraction or not. It's related to what is it asking for. So if you're told to find the square roots and they are not giving you the symbol, it is assumed you want both the positive and the negative version. So it's unrelated to what is in the square root. It's what they're asking for. So we are not given the symbols. So we assume both. And negative. So that's why we use the positive and negative. And a lot of people forget that. And so that's sort of why I was like going through, and then it was like, oh, but don't forget, we also have the negative because it's not specifying. It specifies when you see it with the symbol, but without the symbol, you're always going to assume both. So back to here, we've got our principal square root of 169. So when you see the word principal square roots, it's assuming the positive square root. And so here we do specifically want the square root of 169 without a negative symbol there. We want the positive one. And so this is the same as asking what number squared gives you 169. Now this is not something that you probably have memorized, but 13 squared gives you 169. So this is something that you might be like, okay, I don't know what this is on my calculator. So you would just literally write down that, put that in your calculator, and it will give you 13. So 13 is the principal square root of 169. So the next says, well, what is the negative square root of 169? So if it's asking for the negative specifically, then we would have the negative in front of our symbols. And then that would tell us that we want specifically negative 13. The next question here, we have which of the following are perfect squares? So perfect squares are things where if you put it on your calculator, you're going to get a whole number or something that you can write as a fraction. And so I showed in Desmos, if the fraction button is there, that means it's a rational number, so that's a perfect square when you take the square root. So I'm actually just going to kind of cross things out here. Or actually, I think I'm going to circle. So for whole numbers, it's really good to memorize perfect squares. So 9 is a perfect square because that will give you 3. 16, the square root of 16 gives you 4. The square root of 25 gives you 5. 36 gives you 6. 64 gives you 9. 121 gives you 11 when you take the square root of that. And then 169 gives you 13. So square root of 9 is 3. Square root of 16 gives you 4. Square root of 25 is 5. 36 is 6. And then we actually don't have a square root that will give you 7 on here, but that would be the square root of 49. Square root of 64 gives you 8. 81 would give you 9. 100 would give you 10. Square root of 121 gives you 11. 144 would be 12. And then we've got 169, which is 13. So I recommend at least memorizing them up to like 13. I actually have 15 memorized, but for whatever reason, I don't have 14 memorized. I just don't see it often, but you will see like the square root of 225, that gives you 15. So you'll see them often enough that you will learn to memorize them, but it's good to make flashcards or something just to have these memorized so that you know which numbers are perfect squares. So perfect squares are numbers where when you take the square root, you're basically getting something that's a rational number. Are there any questions? Okay. So moving on here, we're told to simplify the square roots. So that means we're going to evaluate them if possible. If they come out to a whole number, we'll make them a whole number. And the symbol is given, and so you interpret it exactly as you see it. If there's a minus sign in front, then you want the negative version. If it's not there, you want the positive version. So because the symbol is specifically written here, it's telling us whether we want the positive or negative version here. So these have the radical symbol. And so are indicating whether we want positive or negative. And all of these don't have the negative sign in front, so we're going to use the positive for all of these because we don't see any of those negative signs. So if it says simplify, you're just going to be putting this on your calculator and then kind of given what comes back out, you know? So I totally encourage you to use your calculator because it'll make your life easier. So when you take the square root of 16, you get 4. You know, you just plug it in your calculator or memorize it. That's going to give you 4. Square root of 81 is going to give you 9. Decimal ones, for sure, use your calculator because, as we saw, I got my decimal place wrong. This comes out to, oops, 0.5. And that is when you simplify and you take the square root symbol disappears. So notice I almost wrote the square root symbol. That would be wrong. The square root symbol disappears when you are simplifying or taking the square root. So you do the action and then you don't need to do it anymore, so the symbol is gone because that symbol is telling you what to do. Now, undoubtedly, I'm probably going to get the square root of 0.09 wrong. So I'm going to just pull up Desmos for that. Square root of 0.09. Okay, so that comes out to 0.3. So another one where I'd probably put the decimal place in the wrong spot. So this is 0.3. The fraction ones are easier for me because I can just take the square root of the top and the square root of the bottom. So for 1/9, that would be 1 over 3. And then for the square root of 25 over 16, it's going to be 5 over 4. Because the square root of 5 is 25, or the square root of 25 is 5. The square root of 16 is 4. Are there any questions? Okay. So here's some more, and these are, you know, they're kind of like order of operation problems. This is the kind of stuff that you're going to be doing when you do the quadratic formula. So a lot of people mess up here. Order of operations, we need to do what's inside the square root before you take the square root. So the square root is kind of it's like grouping. So it's like the parentheses step in the order of operations. You need to simplify inside before you do the square root. And this is where it's really important to see what's inside the line, because you need to know what is included in our simplifying and what is not. So we need to simplify inside, then take the square root. So square roots do not work where if I did the square root of 64 and then the square root of 36 and added them together. It does not work that way. You won't get the right answer. So you have to simplify inside, then you do the square root. So for 64 and 36, I have to add those together first. So 64 plus 36 is 100. So when I add it, I still have the square root symbol because I haven't taken the square root yet. Now I'm going to take the square root. And the way it was originally written didn't have any minus signs, so we're still using the positive version here. So the square root of 100 is equal to 10. And so that's how you simplify it, is you have to combine inside first, then take the square root. If you did it the other way, if you did the square root of 64 plus the square root of 36, you would get 8 plus 6, which does not equal 10. Your answer would be wrong. So have to do inside first. So same thing on the right, we've got 16 plus 9, which is 25. So I have to make sure that I write that square root symbol over it. And then that gives you 5. So same thing with the 2 on the bottom with the subtraction. So let's make this a little interactive. Let's have you guys use the chat. So I want you guys to do the last 2 problems on this screen where you're doing the subtraction. So do the subtraction first, and then use your calculator, or if you happen to know it yourself, take the square root. But you're welcome to use a calculator, but then find the square root. And then when you find it, you can put your answer in the chat. And so you can just say, like, for A, so let's just call this one A and this one B. So do both A and B. And this is good practice so you can make sure you use your calculator correctly. Okay, so we've got an answer for A. I'm going to just wait and see some other people get some answers. Okay, another answer for A. All right. So I like looking at the chat because I see very common error. I see a mistake that actually I see a lot, so that's perfect. A lot of people will do the subtraction and then forget to actually do the square root after that. And that's why it's so important to write these down, so that way you can write down what you have and then move to the next step. So for A, you're doing 169 minus 144, and that gives you 25. So you have to make sure to remember to put that square root symbol over it. So the way that I write it, I put 25 first, and then I do the square root. And I could see where you could easily forget to put the square root symbol because you're not done and you think your answer is 25. But your answer is 5 because then you have to take the square root. So if you find yourself making that kind of mistake, you might want to write the square root symbol first. So for B, you do 225 minus 144, that gives you 81. So if you think you're going to be making that mistake a lot, write the square root symbol first and then write the number inside it. So that way you don't forget it. And then you take the square root of 81 and you get 9. So great job. You guys did great. I'm glad that we got that discussion with forgetting to take the square root because it's very, very common. Okay, so these are my last page of examples, and now here we're throwing in some negatives. So this is going to really, you have to be very careful. Is the negative on the inside or is the negative on the outside? Because it matters. It matters. I've got one with a negative on both. It really does matter. So we've got negative square root of 4. If the negative is on the outside, that means you want the negative answer. So I'm going to just write that in blue. Negative on the outside equals negative answer. So for negative square root of 4, you take the square root of 4, and then you're going to have a negative answer. So one way that you could interpret this is you do the square root of 4 first, which is 2, and then you have your negative out there. So if you kind of get confused with that, you can think of, I'm doing the square root and then I've got my negative sign separately. So that's going to give you a negative 2. Now, if the negative is on the inside, there is no real solution or real numbered square root. So for the square root of negative 4, no real numbered square root. So negative on inside, not a real number. So you don't get -2 out. It doesn't work that way. So on the right, we have square root of -4/9. That negative is inside, so that's going to be not a real number to square root, or you can write not a real number. That's usually what I do, is shorter. Bottom left. So we've got negative square root -1/36. So we've got a negative on the outside that tells us that we want the negative answer, but we also have a negative on the inside. What matters the most is the negative on the inside. The negative on the inside tells us this is not a real number. It doesn't matter whether we have a negative on the inside it doesn't matter if we have a negative on the outside, because you don't have negative not a real number. If that negative's on the inside, it's automatically not a real number. And so one thing I want you to really notice here is that you cannot multiply a negative on the outside by a negative on the inside of the square root. Those cannot multiply together. It doesn't work that way. So the negatives here don't cancel, and you don't get a positive out. So you cannot distribute inside the square root. The square root is a very different thing. It doesn't cross that square root. The next one is negative square root of 400. So we have the negative on the outside, so we're going to want the negative answer, and then you're going to take the square root of 400. So let's say I just bring up my Desmos calculator here. Square root of 400 is 20. So because we have the negative on the outside, we're going to get a negative answer. And you can even type that into your calculator like that, and it will take care of that for you. So if I type it in exactly as I see it, the answer is -20. And then on the right, we have the square root of -900. The negative is inside that square root again. So again, this is not a real number because it's on the inside. Are there any questions? Okay, I don't see any questions, so I'll stop sharing my screen. So that's basically what we're doing with square roots. Now, your homework, you're going to have some more complicated kinds of things, but what you're really going to need to learn for this class is just basically, how do I do it on my calculator? Because you're going to be approximating it. If you get like a decimal version, you need to know how to round it on your calculator. And you're going to really need to know how to do the quadratic formula, because you end up having things inside that square root you have to simplify. You have to follow the order of operations. So you're going to be squaring, you're going to be multiplying, you're going to be subtracting. And you have to make sure to know to do all of that first before you do the square root. And you are going to be seeing the plus or minus symbol with that quadratic formula. So you're going to really want to pay attention to that, and then pay attention to, if I get a negative inside here, does that mean I have solutions? No. Negative inside, you have no real solutions. So I know some of the reading is going to talk about things where you're taking a square root and you're splitting it up into different parts, and you're going to get like a 4 on the outside and then another number on the inside part. That's good to know, but that's not the important part we want you to get from this week. That's something that you'll see again in college algebra. So the important part that I want you to focus on this week is just being able to take square roots of things that are whole numbers, be able to put it in a calculator and get a decimal, be able to simplify and know whether you're going to get a negative and if you have an answer or not. So don't freak out too much about that other stuff, because you will see it again in college algebra if you have to take that class. If you don't worry about it. That more complicated stuff is not going to be on your quiz, because we're going to be focusing on the basics. Any lasting, any questions, anything that I haven't addressed that you have a question on? All right, I don't see anything. Well, thank you guys for showing up. I made sure to actually click on the correct link today, you know? One more time. What do you want me to say one more time? When do we have to put negative and positive answer? Okay, excellent question. If you are told to find the square root and they don't give you a picture of math with the square root symbol. So if you don't actually see the math part and it's said in words, find the square root, give both. If you see the square root symbol and it's got plus and minus, then you give both. If you are solving, if it says to solve, you give both. Any other time, you just basically do what you see. If it doesn't have a plus in front of the symbol, then you give the positive. I mean, if it doesn't have a negative in front of the symbol, if there's no negative in front, give the positive. If there's a negative in front, give the negative. Any other time, plus or minus, you're not seeing the symbol, you're told in words, or you're solving, and solving, they will actually usually give the plus or minus. Those you give both. So it's important to keep track of those things. So you might want to, maybe make a flashcard or something where you give an example. If it looks like this, give both. If it looks like this, give the positive. If it looks like this, give the negative. Just something so that you can put that together. And then you've got something that you can look at later that will help. And you can use my notes when I sent out this PowerPoint. You can use that to help you grade that. So I recommend doing that for all of, if there's things in your notes that you're like, oh man, I'm confused. When do I do this? When do I do that? Especially because you don't always learn them at the same time. It's like compile it all together on one piece of paper so that you have like something to look at. It's great note-taking skill. It'll be very useful on the quizzes, and then you've got this thing that you can look at. Oh, it's this, I do this. So good skill that applies to a lot of things in math, and I would definitely do that. Any other questions? Okay. Thank you guys. Thank you so much for coming and participating, asking questions. I really appreciate it. And I will see you guys next week. So take care. Bye. Yeah, I hear thunder, so I think we're going to be getting rain. I've been like, what is that? So hopefully you guys have a nice sunny weekend. Bye.